Okay, the graphs of logarithmic functions, we can look at the examples of exponential. We have here 10 to the power of x and e to the x. So the logarithmic, the inverses of them would be log of x and natural log of x. So the domains, all real numbers for the exponentials, all positive real numbers for the logarithms. The range, all positive real numbers for exponentials and all real numbers for logarithms. Now, reminder, those are inverses of each other, so that means that the domain for exponential and the domain and the range for logarithm are the same, and the range for logarithm and the domain for logarithm and the range for exponential. Okay? And then they refer to some other information there. Okay? So transformations. Okay? Here was our main transformation form that we looked at. So C times f of a times the quantity x minus b plus d. So a reminder what they are. A is a horizontal stretch or compression, and we use or I should say, and also it's a reflection if it's negative. So if A is negative, it's a reflection over the y-axis. If it's greater than 1, it compresses. If it's less than 1, it's a stretch. Okay. And here we show that in number 2. B tells us whether we're moving left or right. C stretches it or compresses it vertically or reflects it vertically. And D is a vertical shift up and down. So we want to describe the transformation. The first thing we have to do is it has to be in this form here to be able to do the transformation. So I've got to take this problem here, number 5, and I have to make sure it's in that form first of all. Okay, is it in that form? All right. That means that if there's basically where it changes if there's a coefficient of x. Okay, there's no coefficient of x except for 1, so it is in that form. So we need to identify the values. So let's look at what they are. A, B, C, and D. What is A? What's B? What's C? And what's D? And then we can do the transformation from there. So in this case, what's the value of A? Okay. The coefficient of x is 1. What's the value of B? Okay, negative 4. Remember, it is a minus here, so it's always going to be the opposite. So this is negative 4. Okay. And how about C? What's the value of C? 3. Okay. And the value of D? 0, because there's nothing added on. So C is 3 and D is 0. Right. So if A is 1, that doesn't change anything. B is negative 4 means it's moved how? Okay, shifted 4 units to the left. C is 3 means it's what? Stretched vertically by a factor of 3. So this is shifted 4 units to the left and stretched vertically by a factor of 3. Right. Now, domain and range. Okay. So let's look at what the graph looks like for a second then. If it's shifted 4 units to the left, here's our graph. So here's the original graph is here of just the log of x. Okay. So then this other graph then has been moved over here 4 units to the left. So we basically put in a vertical asymptote then at negative 4. So the new graph is stretched out and is shifted over 4 units. So that means that this value here would be at 1, where this value here would be at negative 3. Okay, where it crosses the x-axis. All right. So let's take our calculator, and I want you to actually graph the log of x and graph this one to see how they compare and verify that too. So we're going to graph the log of x first. And then 3 log of x plus 4. And then use your standard viewing window. So if I go to my window, or the graph, table, excuse me. There we go. At 1, it's 0 for log of x. And at -3, it's 0 for 3 log of x plus 4. So it's been shifted 4 to the left because of those points there when x equals 1 and when x equals -3. All right, let's look at number 6. And the range doesn't change because the range is real numbers, all real numbers. It's still just going to be all real numbers. Okay. So number 6. So the first thing I've got to do is I've got to write it in that form. We have to put it in the form c times f of a x minus b plus d. So we've got to change it to that form first of all. So what does that mean has to happen here? What do I need to do in this problem then? Okay, we need to, first of all, we need to switch the x in the form. Okay, so h of x equals the natural log of -x plus 4 plus 2. Okay, what else? Is that done then? Or do I need to rewrite it again in a different form? I need to take out the negative, right? Because there is a value of a here, and the value of a is going to be -1. So I need to rewrite it so that the negative is on the outside. Well, what does that do to the 4 then? Yeah, makes that a negative. Right? So this changes our perspective a little bit for the values of a, and b. Okay? So now, right, what's the value of a in this case now then? -1. Okay? And if it's negative, that means it's going to be a reflection then for a. What's the value of b then? 4. Okay. C is 1. And D is 2. Okay. All right, so this graph has been shifted to the right 4 then, correct? Well, the last one was shifted to the left 4. Since this one shifted to the right 4, that means our domain is going to be, okay. Well, up here we said the domain was greater than, x is greater than -4. In this case then, x is going to be greater than +4 because we're going to move it to the right. So what do we know? Domain is going to be x is greater than the value of b. Okay. If there is no value b, then it would be 0, right? 0. Okay. So the domain for a logarithmic function is always going to be x is greater than b. And what about the range? Yeah, the range is always going to be all real numbers. Okay. So here, this graph is, because A is negative, it's reflected over the y-axis. That means it's going to go, oh, wait a second. Oh. Which direction is this graph going? Okay, it goes down 2, and it's going to be moved 4 to the right, correct? But what does this tell me right here? What's that negative tell me? Use a different one. What's this tell me? Since it's negative, it's reflected over which axis? The y-axis. Okay? So if it's reflected over the y-axis, that means it's going which direction? To the left or to the right? This might change things, change this a little bit. Okay? Reflected over the y-axis. So if the normal graph of the natural logarithm looks like this, if it's reflected over the y-axis, which direction does it go? Okay, so this graph is going to go to the left, so it's going to go this way. Okay, and then we said it's shifted 4 units to the right, so that means it's over here. Oh, so what does that do to our domain then? Now it's going to be less than instead of greater than. Okay. Oh, except if we have a reflection. Okay? So there's a little curveball to that. Okay? All right, so this has a horizontal reflection. It's shifted 4 units to the right and up 2 units. So the domain is going to be x is less than 4. But wouldn't that make sense that if the domain is normally greater than b, if I have a horizontal reflection, a horizontal reflection means that we have negative x. Well, then what happens? That changes the direction of the inequality, doesn't it? Okay? So you have to remember those things. Okay? So what would be a better idea than to always say domain is x is greater than b? It would be a better idea to make a sketch of the graph and make sure you're going the right direction. Okay? So if a is positive, it's always x is greater than b. If a is negative, it'll be x is less than b. Okay, if you invest money at an interest rate r, compounded annually, then T of r gives the time and years that it would take to triple. So how long would it take to triple an investment of $500 at 5% annual interest? Now, the reason I asked about question 33 earlier, all right, and what did you tell us, Alyssa, was the answer? Right. Okay. The interest rate affects how long it's doubled. Well, notice this. Look at this formula here. Right? We're talking about something tripling. Does it have anywhere in that formula the initial value? No, it doesn't. Okay? So the amount of money that's invested has nothing to do with how long it takes for it to triple. It's totally involves the value of R, which is the interest rate. So if we want to find out how long it takes to triple this investment, we're just going to put what number in for R? 0.05. All right? So plug it in your calculator. Okay, letter B. What annual interest rate is needed in order for the investment in Part A to triple in 15 years? All right, so we need to find R. So where is this 15 going to go? Where does 15 go in our formula? Where does it go? Okay, and for t of r. So we get 15 equals the natural log of 3 divided by the natural log of 1 plus r. Is that something I could put in my calculator and solve? Definitely. So y equals natural log, well, let's make our fraction. Natural log of 3 and natural log of 1 plus x in the denominator. And we want to know when it equals 15 years. So before you find the answer, right, do you think it'll be more or less than 5%? Because in the last question we had 5%, and it took 22 and a half years to triple. Do you think this will be more or less than 5% then? Okay, probably less since it takes less time, right? Oh, wait a minute. If it takes less time to triple, the interest rate's got to be greater then, doesn't it? So in this case, we better get a number that's larger than 5%. Okay. So let's see. Let's use the window we had. Let's see what I get here. I don't see anything. What am I missing? Help me out with this window. Okay. What's my y max need to be at least? 15, right? Okay. All right, so let's go y max to 20 so we can see that. Okay. I still can't see where it intersects. Why not? What? What's the x value need to be? Okay. It's, well, we know it's got to be bigger than 5%, but 5% is equal to what? 0.05, all right? So we need to change our window here. So we'll start at 0 because I don't really care about negatives. And let's go to 0.15. That would be 15%. I don't think it's going to be 15%, but we'll find out. All right, now let's graph it and see what we get. And there we go. So find the intersection point. And it is approximately 7.6%. 7.6, right? Okay. So this would be R is approximately 7.6%.